In this video, we work kind of in reverse where we're not given the equation of a parabola and graphing from it. Instead, we're told some information about a parabola and we need to come up with the equation and also the graph. Okay, lots of times you won't be asked to graph, but the graph is a necessary component in order to determine the equation. So we're going to do both here. So the first thing we need to do is kind of plot what we're given, a vertex at -1, 2, and a focus at -1, sorry about that, that should be +1, -1, +1, and then we will try to glean some information from this, okay? So the first thing we probably should do is start with an x-axis and a y-axis. So perhaps my y-axis will be like right here. Sorry, I have so much trouble getting this program to do what I want it to do. There we go. And they're both above the x-axis, so maybe our x-axis is like right here. Okay, so no problem. We've got both axes drawn. And next we'll set up a scale. Since our focus is only 1 unit from our vertex, maybe we will use 2 tick marks for every one. So this will be 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, etc. So, okay, let's get started. Let's plot the ordered pair -1, 2, which will be right there. That's our vertex. And our focus is -1, 1, which is right there. Okay? So this is our focus. This is our vertex. We can tell this parabola is going to open down. Opens down, which means that it's going to look like this, which means that we have symmetry left to right, which tells us that x will be squared in this equation. So our goal, remember our x squared equation looks like this. Okay, so that's what we're wanting our equation to look like, okay? Now, we do know our vertex is the ordered pair -1, 2. What that tells us, if you remember, the vertex relates to the numbers that go inside here next to x and y. So x is -1, that tells us the equation will have an x plus 1 because they're opposites. And y is 2, so y will be y minus 2 because those are opposites. So at this point, we have an equation that looks like this. X plus 1 squared equals an unknown number times y minus 2. We're almost done with the equation, okay? Now, from our vertex and our focus, we can get a couple different things. We can get our p-value. So our p-value is the distance between our vertex and our focus. So p is going to be, and since I'm going down, I'll say p is -2. So p is -2. And so I also want to measure 2 units. I'm sorry. Every 2 grid marks is 1 value. So p is actually -1. Glad I caught that. P is -1, which means I also need to go 1 in the other direction to locate my directrix. So my directrix is right here. And we could write that down. The directrix is at y equals 3. It crosses the y-axis at 3, okay? Y equals 3. All right, very good. Now we know our parabola is going to open downward. We just need to know how wide it is. So if p is -1, that means our focal diameter is going to be 4 times, and since focal diameter is positive, 4 times our p-value, we'll multiply 4 times +1 to see that it's 4 units wide. So our focal diameter means our parabola is 4 wide. Now remember, our focal diameter is measured through the focus. So I go to my focus and I need it to be 4 wide here. What that means is I need to go 2 units on each side of the focus to get a total of 4. So I'll go 1, 2 units to the right, and I'll get this point, and I'll go 1, 2 units to the left and I'll get this point. That's precisely the endpoints of our lattice rectum. So let's write those down. Endpoints of the lattice rectum. So the point on the right is the ordered pair 1, x is 1, y is 1. The ordered pair on the left, x is -3, and y is 1. Okay? And now I can graph this parabola. So I've got the graph part done. I still need the equation, and all I'm missing in my equation is this guy. Well, that's my focal diameter, okay? So now I can write my equation, x plus 1 squared equals 4 times y minus 2. Now, if you want, you can call your focal diameter -4, right? Because p was -1. That can be helpful because this really should be a -4 since the parabola opens downward in the negative direction. Remember, this number is negative if the parabola opens in the negative direction. So this is the standard equation for this parabola. So we have our graph, and now we also have the equation. We've also labeled the directrix, we know the focus, lattice rectum endpoints, the p-value, everything we need for this parabola.